All right, so moving on to lesson 3, we are going to be focusing specifically on binomials and how to work with those. So all that a binomial is the polynomial that consists of two terms. So a polynomial just means any number of terms. Binomial means two terms. Trinomial means three terms, and typically anything above 3 we'll just call a polynomial for our purposes. Oh, and monomial is one term. So for instance, a binomial just consists of two terms. So example, x plus y, a plus b, c plus d, 2y plus 2d is a binomial. Anything that has two variables in it. So if we are expanding binomials, that means that they are to a power of something. So here we just have our brackets, sorry, to the power of 2 over here to the power of 3. All that it means is that we're going to use distributive property. So for instance, I would just rewrite this as a plus b times a plus b. And then I'm going to use my distributive property through. This would be a times a is a squared, a times b is a b. And then here, b times a is ba, b times b is b squared. These are like terms, so I'm going to collect them, and I will get a squared plus 1 is 2ab plus b squared. And that would be the expanded form of the binomial a plus b when that is to the power of 2. So if we do the same thing as a plus b to the 3, that would be the same as writing out a plus b times a plus b times a plus b. And now I can do that same process over again. I'm just going to simplify this down for the note. I know this is the same as this one, so that will just be a squared plus 2ab plus b squared times a plus b. And again, now I'm going to multiply this through. This would be ab squared plus 2a squared b plus a to the power of 3 and b to the power of 3 2ab squared. Oops, I'm running out of space, and that's getting 2ab squared plus a squared b. I can then go through and collect my like terms if I have any, which I do not have, and that would then be my final answer. Awesome. So now we can then start talking about binomial systems. This is something that you might be familiar with from linear systems from grade 9. We're going to bring that back up. I just want to teach a method that will help us out when we get there. So this is the method that we call elimination. So essentially, when we talk about binomial systems, it means we have two sets of binomials, and we want to find what both variables are equal to. So in the elimination method, essentially what we are doing is we are going to add the equations together to get rid of one of the variables, because we don't know how to solve an equation with two unknown variables yet. This is a way that we would do it. So when we are doing this, it's essentially that they're going to cancel out. So we want two variables with the same coefficient of opposite signs. This way that works. And I'll show you what that looks like in a second, because I'm aware that whole paragraph just sounds like a whole bunch of math nonsense. But if the signs are not the same, so that means if we have a positive and negative, we are going to add the binomials together. If the signs are the same, say I had a positive 4y and a positive 4y, I would then subtract the binomials. Now, when we're doing this, it will seem a little bit like you're using common sense to determine which variable to eliminate and get rid of, and that is fine. But what we are doing here is, say for the first section, I want to circle which variable I'm going to eliminate. So if I take a look here, this is going to give me negative 4y plus 2y would give me negative 2y. That's not getting rid of my y though, because that would still be in my final answer, because I'd have to add these together and I'd get 2x minus 2y equals 8 minus 6 is 2. And that would not get 1 on its own. Now, if I look here, I can see x and x. They are to the same coefficient. So I'm going to circle these two. Now, because the signs on them are the same, that means I'm going to add both of these subtract these binomials from one another. So when we do that, x minus x is 0x. Negative 4y minus positive 2y is negative 6y. And 8 minus 6 is 2. So if I rewrite that, I would get negative 6y is equal to 2. Now, we are not going to solve it this step. So I do not solve. But that will be the next thing that we do. I just want to get used to eliminating variables first. If we move on to the second equation, I can see that these are not to the same coefficient, which might make it harder, but these two are. So again, they're both the same sign. So I'm going to subtract them. X minus x is going to give me nothing. Negative 4. These are the same exact equation. So I'm just going to scribble this one out because it's the same as right here. Okay, let's move on to the next one then instead. I can see negative 3x plus 2x. They're opposite signs, but the coefficients are not the same. And if I look at y, I can see positive 6 and negative 6. So I'm going to choose these two because positive 6 minus negative 6 is going to be equal to 0y. So in this case, the signs are opposite, so I'm going to add them together. So negative 3 plus 2x is going to give me negative x plus 0y. 9 plus 4 is going to give me 13. So if I simplify that down, negative x is equal to 13. And now we have x on its own, which means it's a lot easier to solve. If we look at this next example, again, not the same coefficient, same coefficient. So here I'm going to subtract the two of them, and I will get 0x. Negative 6y minus positive 4y is going to give me negative 10y is equal to 17 minus negative 3 is the same as 17 plus 3, which is 20. So my final answer is negative 10y is equal to 20. Here I have negative x and negative x, and then 13y and negative 15y. So because they're the same sign, I am going to subtract them from one another. So negative x minus negative x is going to give me 0x. Positive 13y minus negative 15y is going to give me positive 28y. And negative 22 minus 6 is going to give me negative 28. So if I simplify that down, I will get 28y is equal to negative 28. And last example we have here, I can see 5 and 2 don't match up, but negative 7 and negative 7 do. Again, they're the same sign, so I'm going to subtract. Negative 5x minus 2x is going to give me negative 7x. Negative 7y minus negative 7y is going to give me 0y. And 27 minus 20 is going to give me 7. If I simplify that down, that goes away. Just going to write that on all my zeros. And I will get negative 7x is equal to 7. Awesome. Now, if we're using this method, we can also go back and now actually solve for what x and y are equal to for both of these statements to be true at the same time. Essentially what it is if we're looking at, this is typically used for like lines on a graph, it will tell you which point those two lines cross. At what point are both of these equations equal to one another? So first step that we're going to do is exactly what we just did. choose a variable to eliminate. Now, you might notice that sometimes you don't have variables that are the same number. We will go over some examples where we would just multiply the entire equation. Then we're going to eliminate that. Once we figure out what the first variable that we did not eliminate is equal to, we can substitute that back into either of the two equations. And that will leave us with one unknown variable, which means then we can solve for that one as well. And then one thing that's always good to do is do a left side, right side check to make sure that that answer works for both equations. So if I'm looking at examples, and we'll do some together so you can see it, I can see right off the bat that I have positive y and negative y. So I know I'm going to add these two together. Y is going to be the variable I am eliminating at this step. So 2x plus x is 3x. These go to 0, and 12 plus 27 is 39. Yep, 39. I can now see that I have x times 3. If I want to get rid of that 3, I have to do the opposite, and this is the same as 3 times x, so I'm going to divide it by 3. Whatever I do to one side, I must do to the other. So that means now I will get x is equal to 39 divided by 3 is 13. Next step that I can do is then plug that back into one of the equations. I typically am a little lazy and will pick the smaller of the two equations, so it's left math work. Doesn't matter which one you pick though, either one will work. So when I'm looking at this, I'm going to pick equation 1, so I'm going to substitute 13 in for x, and I will get 13 plus y is equal to 12. This is minus 13, so that goes to 0. Whatever I do to one side, I must do to the other. So y is equal to negative 1. So my solution for this should be 13, negative 1. Remember, this is an ordered pair of x, y. And it works because we have two x's and y's there. Now, if I plug both of those in, I'm just going to type this into my calculator, or I'll write it off to the side. So we're going to do a left side, right side check. That means I have 13 plus negative 1 is equal to 12. 12. That's equal. That's equal. If we look at the second equation, so I have 2 times 13 minus negative 1 is equal to 27. 2 times 13 is 26. This gives me plus 1, 27. That checks out as well. You can just do these on your calculator as well, unless the question specifically tells you to show your left side, right side check. Now, if we move on to example 2, I have positive 3x and negative 3x. Right off the bat, I can see that's the one I want to eliminate. So that's going to go to 0, which means I'm going to add these together. 2y plus 4y gives me 6y. Negative 1 plus 7 gives me 6. I want to get y on its own, so I'm going to divide both sides by 6, and that will give me y is equal to 1. If I am looking for x, what I'm then going to do is resubstitute that back into one of the equations. So I am going to pick the first one, and it's going to be 3x plus 2 times 1 equals negative 1. 3x plus 2 equals negative 1. I'm going to bring this to this side and do negative 2, because essentially I'd just be doing negative 2 there and making them both go to 0, so I can just move it across the equal sign and flip the sign, which means I will get 3x is equal to negative 3, and then I can divide both sides by 3 so that I get x is equal to negative 1. So my solution for this one should be, negative 1, 1. If I do a left side, right side check on that, I can see 3 times negative 1 plus 2 times 1 equal to negative 1, which is correct. If I type that into the bottom, negative 3 times negative 1 plus 4 times 1 equal to 7, which is correct. So that's correct, that's correct. We have 2 last examples to do here, and then we are done for this lesson as well. So when we take a look here, I am going to okay, so this is an example of where we are going to have to multiply I can see that these are not matching up on either side. What I can do is if I take a look, I can't times 2 by any number to make it equal to 5, but I can times x by 3 to make it equal to 3. So I'm actually going to multiply this whole equation by 3. So what I will end up getting is negative 3x plus 15y is equal to 21. You must multiply it through every single step. And then I'm just going to write the second equation below it. 3x minus 2y is equal to negative 6. Now I can see right off the bat, this is the one I want to get rid of. Because they're opposite signs, I'm going to add them together and I will get 15y minus 2y is 13y is equal to 21 minus 6 is 15. So y is equal to 15 over 13, which does end up being an odd number. Do not stress about it. Sometimes that is how it works out. So now what we are going to do is plug that back into 1 so that I can hopefully figure out what x is equal to. I'm going to pick the second one, so I will get 3x minus 2, 15 over 13 is equal to negative 6. So 3x, negative 2 times 15 is negative 30 over 13 equals negative 6. This we're going to bring on this side and have it positive 30 over 13. So 3x is equal to negative 78 over 13 plus 30 over 13. Negative 78 plus 30 is negative 48 over 13. We're just going to move this up here so I can finish it off. So that means 3x is equal to negative 48 over 13. This is a much harder example too, so do not stress if it feels a little bit overwhelming. Which means I'm going to divide both sides by 3. This is the same as saying divided by 3 over 1, which means I would multiply by the reciprocal. Which is negative 48 over 13 times 3 is 39. I'm going to condense this one down a little bit, just make it a bit smaller. But again, that would be like an absolute level 4 mastery type question. If you could do this one, this is... If you could do that one completely on your own, it means you have absolutely mastered the concept and you have nothing to worry about here. So now, next one that we're going to do is I have D, which is 3x plus 4y equals 7. 6x plus 2y equals negative 3. So I could multiply either the bottom equation by 2 or the top equation by 2. Whichever way I do it, this will work out. I am going to multiply the top one by 2 just because it's the first one there. So that means I will get 6x plus 8y equals 14. That then gives me 6x plus 2y equals negative 3. And because these are the same sign, I am going to subtract them. So that would leave me with 6x minus 6x is 0. 8y minus 2y is 6y is equal to 14 minus 3 is... 14 minus negative 3 is 17 over 6 over 6. Y is equal to 17 over 6. Awesome. I am going to write up the answer key for this one and post that up for you, but you can give that one an attempt on your own. And other than that, that is the end of this lesson.